Awesome. So next up, we have Rachel Street talking about AEON as a collaboration tool, and I will let you elaborate on that.
So you can hear me better. There we go. But before I begin, allow me to thank all my collaborators. Obviously, there are a great many people involved in all of the work that I'm about to show you. So after the first session of this morning, I don't want to dwell too much on the motivations for doing multi-wavelength follow-up of discovery alerts. We heard many different use cases. But here I'll simply point out that in order to achieve follow-up of many different alert cases, we need to coordinate observations from a number of different facilities, both in ground and in space, and over a range of different timescales. And the goal of the AEON Plus collaboration is simply to enable that kind of responsive follow-up, both by optimizing the telescope operations, but also the astronomer side tools to enable us to achieve the kind of responsive time domain follow-up across different wavelengths and different telescopes. This enables us to follow up discovery alerts, but it also enables us to have much more flexible observation scheduling modes and the telescopes to be more responsive, but at the same time to minimize the disruption to telescope operations on a daily basis, and to develop the kind of software tools that really enable the workflow. In order to do that, we identified two key capabilities that were really necessary. One was that at least some time should be available on each of the observing facilities in queue scheduled time, and/or to allow target of opportunity overrides. This allows the observations to be requested by the user community through some kind of online platform, but for the observations to be conducted by the observatory staff or robotically. And the advantage of queue scheduling here is that it allows you to interleave different observations from different programs, and that is a much more efficient way to enable the kind of longer-term monitoring, as well as the kind of TOO-driven rapid interrupt. Excuse me. Software here becomes an essential tool because at the observatory side, it really helps observatory staff to have some kind of software to rebuild the schedule after a TOO rather than have it interrupted. However, this doesn't imply any constraints on how those observations are actually conducted at the observatory, be it manual or robotic. The other aspect, the other requirement, is to have some kind of means to submit observation requests programmatically. This is either through some kind of online interface or client where the astronomer community can describe the observations they request and simply send them in. If this has API capability, this enables much more efficient workflows from the astronomer side using tools such as the target of observation managers or Marshall systems, which can really automate the workflow and speed up the response. So AEON began as a collaboration between Noir Lab, LCOGT, Gemini, and SOAR observatories, and has since expanded to include a number of the major facilities in the US and elsewhere. I did want to pause for a second and highlight some fantastic work by the Noir Lab team to bring in the Blanco 4-meter telescope to the AEON network, starting with the new firm spectrograph, but now DECAM will also be available in AEON mode from 2026B. In addition to the AEON Plus collaborating facilities, there's a number of other facilities worldwide that are compatible and meet some of the requirements. These include the SAO, the Intelligent Observatory System under development there, the ESO facilities, the Liverpool Telescope, and they're not confined to the ground either with the Swift Space Telescope. We're also collaborating with a number of observatories contributing to the Rubin in-kind telescope time program. So the goal of AEON Plus is to extend AEON for multi-wavelength follow-up. This includes a number of different aspects. One is building on observatory side software to enable them to meet AEON requirements. Also developing astronomer-facing standalone software library to enable smoother observation requests. And it includes some community coordination opportunities, which I'll come to later. The first is development at the Canada, France, Hawaii telescope on Mauna Kea. They support a number of optical and infrared instrumentation. They're already 100% Q scheduled, so they're focusing on refactoring their Kealahu software. They have just released a new version of Kealahu, which has been refactored and now has APIs for target creation. The next phase is to enable the submission of observing templates. And lastly, they'll get to improving their rapid TOO response. We're also working with Keck Observatories. They have developed APIs for their TORT platform, and that allows integration with TOM systems and marshals to submit target of opportunity requests. They've also upgraded their online interactive platform for requesting observations. We're working with the Skynet robotic telescope network. This is particularly interesting because it includes a large number of optical telescopes, but also 11 single-dish radio facilities. They're in the process of developing version 2 of their software platform, which will include APIs. That's just entered a testbed phase, so we're looking forward to integrating with that shortly. And last but not least, working with the Skynet network will enable us to build on that to work with the National Radio Astronomical Observatory. They are in the process of building their next platform for the NGVLA system, and we're collaborating with that to enable more time domain friendly observation modes. Now, on the subject from the astronomer side software, in coordinating observations across multiple platforms, astronomers are faced with kind of a proliferation problem. We have a lot of different platforms. Everybody builds their own, everyone has their own software, everyone is different. And me as an observer, I want to observe on all of these things. There's a lot of reinventing of wheels if I have to talk to every single different platform. So we're developing AEON which is a single Python library, which is designed to communicate with multiple telescope facilities and abstract away as much as possible of the detail so that it's a common user interface for as many telescopes as possible. And thereby making it as a form of a Python library, it's designed to integrate with other user platforms. Now, these include not just TOM systems or marshals, but everything down to Jupyter notebooks or your own custom pipeline. So it provides some relatively straightforward different class objects, sidereal targets, the window of your observations. It doesn't enforce a unified request language because every instrument has its own modes, has its own filters, etc. So those are still available to you for the individual observatories that you want. It uses AstroPy quantities and Pydantic to ensure user-side validation, which helps to verify the observation request before it gets to the telescope. Now, I mentioned we have some aspects of community development as part of the AEON Plus program. This was motivated by the fact that we have a number of platforms for astronomers to come and say what it is we want, but not so many for the observatory staff to come to such meetings and hear what it is we want, and also to talk to one another, to share experience and to share tools. So we have two different opportunities as part of this program. We have a visiting developer program to enable the developers of astronomer side platforms or observatory side tools to meet with one another, to share that experience, to share that platforms, and to share software. And we also have an annual Observatories Forum. This picture was from the Observatories Forum last fall, which was a great one. I hope a number of you were here. We're just about to organize the next one, which will be in late October, so please save the date. The meeting organizers asked us to talk about a number of key points, so let me deal with those. In terms of what we've learned from the existing alert streams, I think observatories have They're covering multiple wavelengths now, and they are becoming much more responsive to time domain alerts. But the amount of time available on large facilities is inherently finite. There's only so much to go around. And what I have experienced as an observer is if you have multiple competing teams applying to the same telescopes, you can end up with duplicated observations, and ultimately you can end up with a lot lower science return overall. So I think community coordination is going to be essential going into the Rubin era. How do we optimize transient discovery? I think more coordination between observers, and there are platforms available for that now, are going to be very important for this. And that enables us to share not only the survey discovery data, but also the follow-up observations in real time. And that then improves the efficiency of follow-up for everybody. But I also think that we need to coordinate more between different fields in astrophysics. It's great if the whole of the supernovae field is all talking to one another. That's fantastic, but you may not be talking to some of your colleagues in, say, the galactic science frame. And I think there is much more scope for sharing more information astronomy-wise. And to touch on the subject of machine learning, I think it's being especially valuable at the broker sides, but in particular, I think from the community's point of view, it's really, really valuable in selecting and prioritizing a finite number of targets out of this massive alert stream. And I think there's more work that I think we can do there. And I'll finish there and take questions. Thank you.
Questions?
Thanks. Rachel, that was a really cool talk. Thank you. I have a bunch of questions and I just have to pick one. The rest will have to be for later. But some of the facilities that you're integrating are already have a queue mode. And so what I'm wondering about is if if I want to get time on a given facility, I can maybe apply through that facilities call, or maybe I can submit to AEON. But how do you make sure that there's no duplication between the AEON side and the native queue? And how do you ensure that, has anyone been willing to sort of adopt AEON completely as the way that they operate their entire queue, to sort of head off that sort of trade-off?
Thank you for this question, because it raises one aspect of this that is very important to emphasize. AEON refers to the communication between the observer and the telescope. It has absolutely nothing on the time allocation at that telescope facility. So you don't apply to AEON for time. What we're doing is we're enabling modes of observation at that facility. It's up to you to apply to whatever call is available to you for proposals. You get your own time allocation, and all of the individual telescopes have their own policy for managing competing proposals as they come in. And we make no requirements on them whatsoever for the allocation of their telescope time. But as for adopting the AEON platforms and the approach, yes, the telescopes that I highlighted in my talk have all adopted it for at least some of the time, and in many cases, 100% of the time.
Awesome. Other questions?
Thanks, Rachel. Kind of related, following up what you have just mentioned. I think it's becoming increasingly needed to have a proposal for a science case and then use that science case to then justify the use of multiple facilities as part of a cohesive observing campaign. I think we're moving in many ways in this direction. Definitely having the technology that enables that is a good step in that direction, like towards this type of planning, this type of time allocation. do you see this happening for at least some of the facilities you've mentioned? Like, do you think in the next like 5 years, will we be able to say, this is the source I'm interested in, and I want to use these like 5 different type of facilities for the follow-up?
I would very much like to see more opportunities of that kind, sort of multi-telescope proposal calls, if you will. And we have done it successfully in the past, but that was a pilot program, and it has been extremely difficult to persuade major observatories to dedicate time to that kind of common program. I think that is going to be something that the community needs to ask for loud and clear. And I think observatories are willing to give it to you, but until they hear that call from their community, they're not going to do it.
We have to stop there. Thanks, Rachel.
Thank you.